Hi everyone, my name is Matt Saywell. This is a video demo of my third year project, which is a thin client computing system. Now, a thin client computing system, also known as Virtual Desktop Infrastructure, or VDI for short, is a solution to consolidate computing power. So by moving the operating system a user interacts with away from a desktop computer, like the ones you can see in the background, to a server, we can better make use of the computing resources available. So most computers sit at well below 10% CPU usage for the majority of the time they're switched on, and this could be quite wasteful as the computer is drawing a lot of power even at low CPU usages. If a whole room's computing is handled by a single server, we're making better use of the processing power that is available and saving energy because only one computer is being used anytime, reducing the idle energy waste. So there are various components involved to make a VDI system work. The primary component is the server. So in my project I'm using Windows Server, and Windows Server runs software called Hyper-V, which is a hypervisor. Now this allows me to create and run virtual machines which the thin clients will then connect into remotely on the server. So this is where the actual computational work will be done. The thin clients will just be connecting in and viewing what's going on the server. So because it's a proof of concept project, the server is installed within a virtual machine. So the virtual machines the clients connect to are actually virtual machines within a virtual machine. So that's known as nested virtual machines. Okay, so the next component of the project is the router. This is also installed as a virtual machine and is connected to the server and clients inside the network using virtual networks. The virtual network connects all the components together like a switch would, but in software. The router allows the devices in the project network to connect out to the internet. Network address translation is used that can manage the addressing scheme inside of the project without causing IP conflicts with the rest of the lab. The router picks up a single IP address from the university's router using dynamic host configuration protocol, and then translates connection requests from IP addresses within the network to a single address so that they can connect out to the internet using the university's router. In terms of physical components, firstly, there was the workstation PC in the lab. This runs the server and the router, as mentioned earlier, within virtual machines using software called VMware Workstation. The dual network interface cards on the back of the PC provide a connection to the internet as well as a connection to the Raspberry Pi computer. The Raspberry Pi is the low-powered computer that's going to be used as the thin client in this project. So a keyboard or mouse and a screen will be connected, hooked up to provide a user input here. Now, it was initially connected to the PC using its onboard interface. However, the onboard interface of the Raspberry Pi only supports 100 megabit per second throughput, and this caused some serious latency in the remote desktop experience. To mitigate this, I installed a 1 gigabit USB interface, which provides 1000 megabit per second throughput, and this drastically improved the performance of the remote desktop experience. So to connect the Raspberry Pi to the rest of the network, whose components are entirely virtualized, the network interface on the PC was set up to provide a direct connection into the virtual network using VMware. This is a demonstration of the system in action. We can see that Windows Server and the router are running on the PC. It's the router, and this is Windows Server with Hyper-V running that client VM that the thin client will connect into. The Raspberry Pi here is connected into the interface on the back of this PC, which then connects directly into the virtual network that these two virtual machines are running inside of. The Raspberry Pi itself is running a Linux distribution called Raspberry Pi Thin Client Project. It's designed for thin client use, as the name suggests, and installed we have our desktop, which is a client for the remote desktop protocol that is being used on the Windows Server and will allow us to connect into the Windows virtual machine and remotely access it. Our desktop is configured to automatically connect to the IP of that virtual machine when opened, to open up a full screen session and to pass audio through to the Raspberry Pi. Once started, the user can simply log in as they would a normal Windows PC. And is then taken to the familiar Windows desktop. So this this operating system we're looking at now is actually running within the computer inside this VM, and specifically it's this VM here. Performance of the virtual machine is generally much better than I expected, and is definitely good enough for office tasks such as PowerPoint, Excel and Word. It's also a very capable web browser, and we can test here the quality of the stream with a YouTube video. So I'm just going to start this up. As we can see, it's not perfect, but the video stream is coming through quite nicely there, and it's certainly, well, it's just about watchable. Audio is also passed through to these headphones. However, I found this is a little bit unreliable with this Linux client, and it's probably something to do with the version of the remote desktop protocol that this is using. So a little bit more research may be needed to look into a different remote desktop client there. The latency experienced on the system is actually considerably lower than what I had expected, and from my testing, people who have used the system have mistaken this for a standard Windows computer, despite me asking them to perform a number of tasks on it. Our desktop, the Linux remote desktop receiver used on the Raspberry Pi, supports an older version of remote desktop protocol than what is now available. We can test the full capabilities of remote desktop protocol by using the Windows 10 connection client in Windows 10. Because this is using the latest version of remote desktop protocol, we can compare the quality of the remote desktop experience. We can see, once it's logged in, that the latency here is lower than that's experienced on the Raspberry Pi, and this is particularly obvious when playing a YouTube video, where we see more consistent refresh rates in the video and fully supported audio with very little latency. This demonstrates the full capability of remote desktop protocol. With a little more research, it may be possible to find a receiver on Linux that outperforms our desktop, so that similar results can be seen on the Raspberry Pi. Well, that's just about it for the demonstration of my thin client system. In the interest of keeping the video light, I have missed out a lot of detail. If you need to know any more detail, you can refer to my dissertation report, or if you want to know any more and ask me any questions, you can send me an email at msaywell@uclan.ac.uk. Thanks for watching.